My previous video illustrated the list or list vector as a data structure in R, and we saw that vectors are either atomic or lists in R. Atomic vectors are restrictive. All of the elements need to be the same type. For example, they all need to be numeric or character or logical. A list vector is flexible. The elements can be a mix of any type. We saw that a handy syntax for retrieving elements from a list is list $, the name of the element that we want to retrieve. Visually, a list is betrayed by the fact that its vectors have different lengths. A data frame is a special type of list with the condition that the vectors are all of the same length, so that we can say a data frame is rectangular. And again, a data frame therefore is a list of equal length vectors. I will code up this data frame. It's not difficult, and we will have column names. And I will include here as a final column what's called a list column, which is handy because we can have a column that itself is a list, so that for each of these observations, we can put whatever we want in the list column. Very handy. If we want to use the correct terminology, we have some synonyms, but we could call the rows are each going to be observations, and the columns we can call variables. If we want to use machine learning terminology, we can call these columns features. Features are columns, observations are rows. And then finally, we went from lists to data frames because data frames are lists, so we would use the same syntax to access the elements in this data structure. To create a data frame is data.frame, and we provide for it the list of equal length vectors. And if we want to retrieve the first column, single brackets 1 retrieves the first column, but mindful of the fact this is a list, single brackets is going to retrieve for us a data frame. If we want to go inside the data frame and get the vector, we need double brackets. The synonym there, you guessed it, is data frame $. Column name is equivalent to double brackets and does not retrieve for us a data frame, but the vector inside, so to speak. Finally, as a rectangle, the data frame is characteristic of a matrix, so we do have the matrix style syntax that allows us to extract from the data frame a data frame based on certain specifications for the rows that we want and for the columns, rows, comma, columns. So I'll show you that in code, and it really covers a lot of what you would need to know for basic manipulation of data frame. As before, I create a notebook file in RStudio. The notebook file format allows me to interactively insert code chunks. And then I just have the view that I happen to prefer in RStudio, which is customizable. I like the console panel down here, and I very much like the environment panel because it gives me feedback as to what objects have been created. And so the first command I'm going to run here is to create a character vector called company. Company is my variable. I'm assigning to it, that's our assignment operator. C stands for combine, where I combine 1, 2, 3, 4, 5, 6 character or string elements into a character vector. Control Enter creates for me, and the environment panel gives me that feedback. Variable company, character vector length 6, starting with the character string apple. And now I'm going to go and just create a data frame. I'm going to call the data frame stocks, that's my variable, assigning to it. The command to create the data frame is natural, data.frame. What is a data frame again? It's a list of equal length vectors. So all data frame needs is a list of vectors that are equal length. The first element in this list is the first column in the data frame. And I'm going to give that column name company. And I'm going to assign to it the vector that I just created, right? So column name is equal to vector called company. The second column in this new data frame called stocks has a column name of sector, and now I'm doing it on the fly. It is also going to be a character vector of length 6, and these are the industries that these companies are in, right? I own Apple stock, it's a technology company. Okay. Third item in the list of a new data frame is a column in the data frame with a column name of revenue, and it is a numeric vector this time. And specifically, you can see with the dollar points, these are sales or revenue in billions of dollars, right? So Apple's about $261.6 billion in revenue, right? These are decimals, so these are not integers, these are numerics, and specifically these are double, short for double precision floating point. But that is the third column in this data frame with column name revenue. And then the fourth and final column that I'll do in the initial data frame creation is called by for the column name. It also is a vector, but this is a logical vector, also called Boolean, right? True or false. This represents whether I currently own the stock. You can see false in the case of Starbucks. I did own it, but I sold it. Now, if I hit Control Enter, then I create the data frame called stocks, and the environment panel, which I love, shows me that I do have this data frame, 6 observations. So those are rows in the data frame of 4 variables. So those are columns in the data frame, or we could call them features as well. However, here's a notorious quirk of R. My first 2 character vectors came in as factors. See, there's categorical variables. Sometimes it's what we want, categorical variables. Oftentimes it's not what we want. Strictly, these vectors are actually integer vectors with attributes. So sometimes it's really not what we want. For this reason, this following parameter is very popular. And I'm going to add it now at the end, comma, strings as factors equals false ends up being useful. Tells R that when you encounter these string vectors, do not please change them into factors or categoricals. Please let them remain as strings, which is what we want in this case. And I'll just rerun. And now I get the data frame that I wanted and that we probably intended, right? First 2 columns are character vectors. So now, just in terms of basic manipulation, let's say I want to add PE ratios as a column to my data frame. And so here's a numeric character vector of the actual PE ratios. And so you can see right here, it's a new variable. It's not in the data frame yet. I add it to the data frame. Pretty intuitively, I take my stocks data frame and then $, same syntax that we saw with lists, because data frame, again, is a list. And RStudio is telling me, well, that list, this data frame, has 4 columns already if I wanted to retrieve one of the columns. However, I don't. I want to create a new one. So I'm going to use PE, which does not already exist as a column, so R is going to create it as a column for me. And to that, I'm going to assign the vector that I just created, stocks PE ratio, and you can see R did this for me. My 6 observations of 4 variables changed to 6 observations of 5 variables, or columns, and here is that new column that I added as numeric. RStudio has this little square, allows me to view this as the rectangle that it is, right? 1, 2, 3, 4, 5 variables or columns, and those are the column names. And then I have the 6 observations. The observations are rows. I do not yet have row names. I just have the index that are created for me, starting with 1. Okay. I can also use cbind and rbind. These are interesting in the base R. So let's say I want to add tickers to my data frame. Here's the vector for that. I'll hit Control Enter. That creates ticker. It has the right length of 6. And then to add it, I can use my column bind. So I'm going to reassign 2 stocks. The column bind, I'm going to put the ticker in front as the first column and the rest of the current stocks data frame after it. So I column bind ticker in front of the data frame stocks, and then I need to remember to use strings as factors equals false so that R does not change these characters into factors. And so that looks good. I hit Control Enter, and you can see it inserts ticker as the column in front as correctly as a character vector, not a factor. And now my 6 observations of 5 change to 6 observations of 6 variables or columns. Now, let's say there's another company. The last company that I bought was Yext as a stock before the earnings. I got lucky and then had a great earnings. And so here's the features of Yext. And I'm tempted to say, let's create the vector yext, but, right, atomic vectors, they need to have elements of all the same type. So if I do this, yext is going, R is going to coerce these elements from least to most flexible, which in practice usually means they all get coerced into characters. So if I execute this, my 0.23 will get coerced into a character, quote, 0.23. These will all become characters. It's not what I want. So, right, we don't want an atomic vector. We want the other kind of vector that's flexible. That's a list. So if I want to add this as a row, because my columns are heterogeneous in my data frame, I need to create yext as a list. And then you can see down here, yext is a list noun. And then I can go ahead and say, okay, stocks, I am going to row bind. This time I'll put the pre-existing stocks at the top, and then I'll row bind yext at the bottom, R bind for row. And you know what, just because I'm insecure, strings as factors, not actually sure I need this, to be honest, but I'm going to do it to be safe. And so now I've gone from 6 and 6 to 7 observations, 7 rows and 6 variables. Let's just hit this rectangle here and just check that. Yext came in just as I wanted. And I'm not sure if I mentioned that for the PE, I use that NA value because sometimes we really don't have a number, but I needed something there for yext. Okay, so underappreciated feature of the, no pun intended, of data frames is the list column. Now I'm going to create a list here of, I'm just going to make up this list, and you can see here it's just a list of 7, keeping in mind that our list, like this yext, can create any elements that we want, including other lists, including our functions, very flexible. And now if I want, I can say stocks. Let me add a new column called LI and assign to it my list. And so that is super cool because my data frame, although my data frame needs to be rectangular, I can have what's called a list column. This column here that I just added, where each element here can hold any object that I want related to this observation. If I want to remove a column, I can say use stocks. I can use the minus sign to remove the first column. I think it's a little more natural to use that $ ticker, or I prefer anyway, to assign null to that column. So if I say, let me just collapse this. If I assign null to the ticker column in the stocks data frame, then you'll note it, then watch 7 and 7 become 7 observations of 6 variables. That ticker column is deleted. I also have here functions to retrieve the column names. These are identical column names of stock and names of stock. Let me move this up. Both return for me the column names. And if I check for row names, actually what I get are those indexed because I don't really have row names. And n row and n column gives me the number of rows and number of columns. The data frame has characteristics of both the list and the matrix. Okay, so I didn't have row names, but I can add them with this command, row names of the data frame stock. And I'm going to assign to the row names that ticker vector. Although it tells me that my lengths are off, and that's because I added that yext as the 7th observation or row, but my ticker vector is only 6. So I'm going to take my ticker vector and append to it the ticker for yext right here, so that my ticker vector is now length of 7, and then I should be able to assign it to the row names for this data frame. And so let's take a look. And you can see now those index of 1 to 7 was replaced with the row names. However, Hadley Wickham says that this is not best practice because the row names are metadata and metadata, after all, are data. And he says that better practice would be to put what we want as row names into their own column. So we can do that very easily by saying, let's say stocks $ticker creates a new column called ticker, and to that column I'm going to assign the row names. So I'm using the row names from the data frame, but instead now I'm moving them out to a column with this command, and then I'm going to delete the row names by assigning null to the row names. And so hit enter, and then if I go back and look, I went back to an index on my row names, and now the metadata, the row names that were metadata now explicitly become data in the data frame and under the column ticker. Okay, now with respect to basic subsetting or selection from the data frame, it's helpful to understand what we did with lists. That's why I did lists as the video before this video in the playlist. I did that because data frames are lists, and so we're basically using the same syntax. It's very helpful to understand that we're operating with a list. So here is stocks in square brackets, single square brackets 1 will retrieve or subset for me the first column in my data frame. And so let's just say, let me just assign that to EG. And what I get is a data frame, right? And this is consistent with the treatment in lists. When we use single brackets to retrieve from a list, what we got back was a list. Here, we're getting back the first column, but as a list, 7 observations of one variable, one column, right? So single, that's the key point. Single brackets here from a data frame will return for us another data frame. Oftentimes we want the vector. And so just like with lists, when we want what's inside the data structure, we use double brackets. That's the way I think about it. I think about it as double brackets means we're digging in further. And so if I instead assign to EG stocks with double bracket 1, then what I get back, you'll notice my EG moved here down to a vector. And in fact, I can go here and just check the structure of the EG and notice I get a character vector, that first column. So double brackets retrieves for me the vector in the data frame, single brackets returns for me the data frame. In both cases, it's a column. As mentioned, the data frame is a blend of list and matrix, being rectangular. So we have the convenient matrix style notation where here's the key. Data frame, the syntax is data frame, and then with our single square brackets, the rows, comma, columns. So this command here, now I'm going to say EG, assign to EG, that from the data frame, I'm retrieving rows 2 through 4 and columns 1 through 2. Control Enter, and you can actually see EG here, and I can also just print it out. I get the columns, I get rows 2, 3, and 4, and you can see they're even indexed here, and columns 1 and 2. If I leave it blank, if I say to EG, I'm going to assign from the data frame stocks, leave the first parameter here blank, I'm getting all the rows and just columns 1 through 2. All right, so if I look at that, EG, I get all of the rows and just the first 2 columns. I actually like, it's old school, but the built-in subset command that's in base R, because I think it's just very explicit. Subset accepts the data frame, in this case stocks, and then we have 2 parameters. Select is where I say which columns do I want to select from the data frame, and subset is where I say which rows do I want, or rows or observations do I want. So I'm selecting from my data frame stocks the sector, although I can combine here, right, inside as a parameter. Let's say I want sector and revenue. So I'm selecting those 2 columns, And then for the subset equal, I want the observations where revenue is greater than 200. So let's see if I assign that to EG for example. So this is why I'm doing that. And then I get EG, and it looks like, so I got sector and revenue as the columns, and the only one that comes back for me with revenue greater than 200 is, let's see, so that's correct. Yeah, that is, Apple's the only one with more than 200 billion in revenue. The tibble is part of the tidyverse, the fabulous tidyverse, and it builds on the data frame. So a tibble is a data frame with additional conveniences is how I think about it. So it has a few different features, but here I've just pulled out 4. The first one is that is really handy. It does not change those inputs like we saw, that inadvertent coercion caused by the data frame. And what that means is we don't have to worry about remembering to include strings as factors equals false. That's very convenient. Second, we can create the list column as we build the tibble. I wasn't able to do that when I added that list column. I created the list and then I added the list to the data frame. We can create the list column on the fly as we build the tibble. That's nice. Lazy arguments, I'll show you that. And then finally, I think the main reason a lot of people like tibble is just has cleaner, more convenient printout, which does come in handy when the data frames get larger. So as usual, to access the tibble, we need the library command after we've installed the package. And then I can basically take my stocks and translate it into a tibble with the as.tibble. And let's see if I do a structure, check a structure on that stocks.tbl, short for tibble, then you'll notice I do get the class. It's telling me that, yes, this is a data frame, but it's also a tibble. So I can do everything. I can treat it like a data frame, but I also get that additional conveniences of the tibble. But I can also just build the tibble as I like with the tibble command here. Control Enter builds my stocks._tibble as a tibble, checking the structure of that. And you can see class tibble. So that lazy evaluation refers to this. If I want to create a tibble, I'll just say EG, where my first column here is a vector sequencing 1 to 5, and then my second column, this is lazy evaluation, my second column in the tibble is a function of the first one that I just created on the fly. So I think that's pretty cool, actually. Right, so if we take a look at EG, you can see here that second column in that tibble created via lazy evaluations. And if I take MT cars as a data frame that's built into base R, and then if I just print it just to show you the clean, sort of convenient output, that's that printout feature of the tibble. That's just a lot cleaner, more convenient than the typical data frame. So it's a few additional conveniences of the tibble, and you can use everything else that you're used to in the data frame. So I hope that's a helpful introduction to mainly the data frame and just the tibble for its conveniences. If you found this video helpful, subscribe to the channel and you'll get notified of the next one. Thank you.